Hello guys. In this video, we'll be discussing what is the grouped frequency distribution and the steps of constructing a grouped frequency distribution. So here are the topics that we'll be covering in this video. So grouped frequency distribution and the steps. So what are the steps of constructing a group frequency distribution? So what is a grouped frequency distribution and steps of constructing a grouped frequency distribution? So if you remember our discussion on simple frequency distribution, right, where we simply had for each class we had one observation or one value or one category, right? Now let's consider this um, this example where uh, we have a data set showing the ages of patients uh, of breast cancer in a city hospital. Okay, so the example that we're considering here is okay. So consider the data set of ages of patients of breast cancer in a city hospital. Okay, and so here is let's say the data set of the patients, the ages of patients of breast cancer. Okay, so let's say 36 and 59, 78, 35, then 53, 44, 19, 88, 39, 47. So then we have 44, 62, 31, then 56, 25, 71, 66, 61, 50, 77, then 61, 58, 73, 52, 67, 49, 33, 70, 55, 64, and then let's say 49, 67, 41, 56, 75, 66, 37, 47, 84, 73, then 57, 38, 48, 69, 86, 81, 72, 55, 53, and 41, let's say. So we have 50 observations here, right? So we have, let's say, 5 rows and 6, 7, 8, 9, 10 columns. So 50 observations we have. And again, like the data in this raw form doesn't give you much of an information. And so let's try to organize this data. Now, what we can do is we can try organizing this data in a simple frequency distribution, right? So for each unique value, we simply we count the frequency and then list them on a table, right? That's what a simple frequency distribution is. And so one way of arranging this data set would be to arrange in the form of a simple frequency distribution. So let's try doing that and see what happens. So if we, okay. So let's arrange the above data in the form of a simple frequency distribution. So if we do that, so let's see how the table would look like when we do that. Okay, so if we arrange, I'll draw it here. I'll write the table. So let's list all the values in ascending order. So ascending order of age, and we have age and frequency. So let's list down all the ages in ascending order of magnitude. So we have 19, then 25, 31. If we simply sort these values, we will get in this order. So then 33, 34, no, we don't have 34 here. So 35, then we have 36, then 37, 38, 39, 41, 44, 47, then 48, 49, 50, 52, 53, 55, 56, 57, 58, 59, 61, 62, 64, 65, 66, 67, 69, and I have to continue to the right of this table because I don't have enough space there. So after 69, we have 70, 71, 72, 73, 75, 77, 78, 81, 84, 86, and 88, right? And so let's count the frequency of each of these values. So we have 19, the frequency of 19 is 1. Then the frequency of 25 is also 1, right? So we have 25 occurring here. So 25 is 1. Then 31 is also 1. 33 has a frequency of 1. 35 frequency is 1. 36 frequency is 1. 37 frequency is 1. 38 frequency is 1. 39 frequency is 1. Then we have the frequency of 41 is 2 here and here. The frequency of 44 is 2 again. Then 47 has a frequency of 2 here and here, right? The frequency of 48 is 1. The frequency of 49 is let's see, 49 is 2 again, right? Then the frequency of 50 is 1. 52 has a frequency of 52 has a frequency of 1. Okay. 53 has a frequency of, let's see, 2. Then 55 has a frequency of 1. 56 has a frequency of 2, right? Then 57 has a frequency of 1. 58 has a frequency of 1. 59 has a frequency of 1, right? Then we have, let's see, 61 has a frequency of 2. 62 has a frequency of 1, right? 64 has a frequency of 1. 65 has a frequency of 2, right? 65 here. And or 65 has a frequency of 1, I believe. Yeah, 65 has a frequency of 1. And 66 has a frequency of 2. 67 has a frequency of 2. 69 has a frequency of 1. Now 70 has a frequency of 1, right? 71 has a frequency of 1. 72 has a frequency of 1. Then 73 has a frequency of 2. 75 has a frequency of 1. 77 has a frequency of 1 again. 78 has a frequency of 1. 81 has a frequency of 1. 84 has a frequency of 1. 86 has a frequency of 1. And 88 has a frequency of 1, right? Now, looking at this distribution, like it is pretty obvious we can all agree that this is obviously not a very good way of representing the data, right? Because it has too many classes, right? Almost as many classes as the number of observations. And so such a listing of data when we have a large continuous data set is difficult and too cumbersome to handle, and it doesn't show any trend, right? So it would be impractical for us to list such data individually, right? And so in a better way of arranging such data would be to arrange it in the form of a grouped frequency distribution. So instead of single values for the classes, what we do is we simply select a class interval, right? Or a range for each class, okay? And so this is what we call a grouped frequency distribution. So some comments here that, so number 1 is that the data arranged in the form of a simple frequency distribution is too cumbersome to handle, right? So doesn't show any trend, right? In the data, right? So too many classes are there. And so a better way would be to arrange the data in the form of a grouped frequency distribution, all right? So for a grouped frequency distribution, we will actually have ranges or class intervals. So now we'll actually discuss the steps of constructing a grouped frequency distribution. So let's see, we are done with what is a group frequency distribution. And then we'll now discuss the steps of constructing a group frequency distribution. So steps of constructing group frequency distribution. So the first step would be to choose the number of classes, right? So how many classes do you want to have for the given problem, right? And so as we saw here that we have too many classes here, right? So the choice for the number of classes is critical, and so you don't want to have too many classes so that like, I mean, it's too cumbersome to handle, and it doesn't show you any trend. And at the same time, you shouldn't have too few classes that obscures any variation in the data, right? So yeah, you have to have a trade-off between the two, and um, which reveals the data and the true underlying trend in the data, right? And there is no right answer for the number of classes for a given problem, right? So we have to try out different values and see what works best. And often, so let me write down this step. So the step one would be, so step one is to choose the number of classes, okay? And there are many, like typically there are different ways you can choose the number of classes. And so let's see. And very commonly, and this is also very effective, sometimes it's effective. So common and effective ways to choose a number between 5 and 20 for the number of classes. And depending upon the number of observations. So if you have too many number of observations, then you can afford having higher number of classes. And if you have too few observations, then you should stick to a moderate value for the number of classes for the frequency distribution. But typically, what is commonly done is to choose a number between 5 and 20. Okay. So a common way is to choose a value between 5 and 20 classes depending on the number of observations. All right. Okay. So the goal is to create classes that would reveal important features of the data, right? For example, the location, location of the center, then the spread, the symmetry, and so on and so forth, without overlooking any key variations in the data, right? So goal is to reveal, is to create classes that would reveal important features of the data, right? For example, center, then spread, symmetry, etc., right? Without overlooking um, key variations, right? And also the number of classes should be manageable for interpretation, right? Should be manageable for interpretation. right? So if you have too few classes, then that can obscure important variations in the data, right? So too few classes can obscure important variations in the data, and too many classes can make the distribution appear chaotic, right? Distribution appear chaotic, and so the final decision is often subjective, and different researchers might arrive at different but equally valid frequency distributions, right? So there are some formal methods of choosing the number of classes for a frequency distribution, and we'll talk about that. Two of such methods. So some other formal methods, and one of them is what we call the 2 to the power k rule. So let's talk about that now. So A is the 2 to the power k rule, and that says that for a large number of observations, we can use the lowest positive integer k as the number of classes for which 2 to the power k is greater than or equal to n, right? Where n is the total frequency of the data set, right? Where k is of course the number of classes, and n is the total number of observations. Okay. And then there is another rule, which is what we call the Sturges formula or Sturges rule. So Sturges rule. And that says Sturges. And that says, so the formula provides a more structured approach for larger data sets. And this says k, which is the number of classes, is equal to 1 plus 3.322 log times log of n, and the base is 10. Okay, so log to the base 10 of n, right? So here I have used an underscore to indicate that this 10 is the subscript of the logarithm or the base of the logarithm, and n is the again the number of observations. So log of n to the base 10, and we have to round it up. Okay, so let's see. So if you take the ceiling of that number, okay, so this is, you have to round it up. All right. So that is how you choose the number of classes for a given problem. to construct a group frequency distribution. Now, the second step would be to find the class width. And long story made short, we simply take the class width as the difference between the maximum and the minimum observation, and we divide by the number of classes, and then we take the we simply round the result up. Okay, so class width is simply equal to, I mean, this is what is done frequently, which is max minus mean, or I would say max observation minus mean observation, and you divide that by the number of classes, and the number of classes, I assume that is equal to k, and then we simply round that up, right? So I round up that result. Let's see. So I'll just write it one more time. So that would be class width is, let's abbreviate that as C dot W equals, this is max observation minus mean observation divided by the number of classes k, and then we simply round it up. Okay, so we take the ceiling of that value. All right, so for this particular problem, let's see, so if we, okay, so here we have total 50 observations, right? So if we use, let's say, Sturges rule, then for our example, the number of classes will be k, because we have n equals 50. So the smallest possible value of k for which 2 to the power k is greater than or equal to 50 would be k equal to 6, right? So if we use 2 to the power k rule for choosing the number of classes, we get k equal to 6. So for our case, using 2 to the power k rule, we have k equal to 6, right? And this is in agreement with this choice of a value between 5 and 20 classes. And we don't have too many observations here. So this is a reasonable choice to make in this scenario for the number of classes. And once we have that number k, now we can find the class width. So CW for our case would be, if we come back to that table, so the maximum observation is 88 and the minimum observation is 19. So 88 minus 19 divided by 6. So this is 88 minus 19 divided by 6, and we have to round that up. So that is so that is equal to this is 11.5, right? 69 by 6 is 11.5, and we have to round it up. So that will be equal to. So this will be equal to 12. Yeah? All right. So the next step would be starting with the smallest value in the sample. Okay. So first we have to form the classes, right? So that would be the next step. So third step would be construct the classes, right? Or construct the classes for the, let me see, distribution. And so the classes, each class will be a range, and so there will be a lower limit and an upper limit. So the first step, or the first sub-step under that would be that to find the lower class limits. So start with the smallest value in the data set or the sample, whatever you call it, and find all the lower class limits. Okay. So we take the smallest value in the sample or in the data set, and we consider that as the first lower class limit. That means the lower class limit of the first class. Okay. So for our example, the lower limit of the first class will be equal to 19. Okay. And then here is what we're going to do. So to find all the lower class limits for all the classes. So we have, how many classes we have? We have 6 classes, right? And so we have to use the class width to find the lower class limit of all the subsequent classes, right? And so what we do simply is we simply keep on adding the class width to the lower class limits to find out the lower limit of the subsequent classes. So the class width is not equal to the class interval. That means not the difference between the upper limit and the lower limit, but it is the difference between the successive lower limits of 2 classes. That means it is a difference between the lower limit of one class and the lower limit of the immediately succeeding class, okay, or the preceding class. So our class width is 12. So 19 is our first lower class limit. And so the second lower class limit will be 19 plus 12, which is equal to 31. And then we have to keep on adding the class width to get all the successive lower class limits. So the next one will be 43. Then we have 55, then 67, and then finally we have 79 because we have 6 classes, right? So these are the lower class limits. And what about the upper limits? So next would be to find out the construct all the upper class limits to complete the construction of classes of the frequency distribution. Okay. So the lower limit or rather the upper class limit of one class is just between so the upper limit of the first class will be just immediately before the lower limit of the second class. So that will be equal to, and we take the closest integer before the lower limit of the next class. So the upper limit of the first class will be equal to 30. Yeah? And then for the next class, the upper class limit of the next class will be 42. And we keep on adding the class width again to find all the successive upper class limits. So 42, then we have 54, 67, rather, sorry, 66, right? Then 78 and 90, right? Okay, so these are all the lower, I will write here. Okay. Lower limits, lower class limits, and these are the upper class limits. Okay. So right. So now we are almost there to construct the table. So now we have the classes, and we also need to list the frequency of each class, right? So the classes are, so the first class will be from 19 to 30, then 31 to, I'll just keep some gap here. So 31 to 42, then we have 43 to 54, then 55 to 66, then 67 to 78, and 79 to 90, right? So these are our classes for the frequency distribution. So what we need to do now is we have to count the frequencies of each class. So to do that, we'll talk about a trick, which is what we call the tally marks, using the tally marks, right? Or the tallies. So I'll add one more column here, which would show the tally marks. And this is a very nice way of counting the frequencies, right? For the frequency distribution. So these are tally marks. So what we do is we simply count. Let's come back to the data set. So we simply take each value and we draw a tally in the corresponding class. So 36 to 59 will be under this second class. So we add a tally there. The next observation is 59. So let's take some values one at a time, some group of values. So 59, 78, 35, 53. So 59 will be here. 78 will be here. Then 35 will be here again. And 53 will be here, right? All right, then come back. 44, 19, 88, 39. 44, 19, 88, 39. So 44 will be here, 19 will be here, 88 will be here, and 39 will be here, right? And come back to the values. And then last one is 47. So this should be here, right? Last one of the first row. So let's come back again. 44, 62, 31, 56. So 44 will be here, 62 will be here, 31 will be here, and 56 will be here, right? Then 25, 71, 66, 61. So 25, 71, 66, and 61, right? 61 is also in this group. Now notice that as soon as we complete a count of 5, we simply draw a horizontal tally to complete a group, so that when you count the tallies, you can count in groups of 5. Okay, so 61, right? And then we have 50 and 77. So 50 will come here. So again, we have completed a group here. And 77 will be right here. Okay. Then 61, 58, 73, 52. So 61 will come here. 58, 73, 52. 58 will be here. 73, 52. 73 will be here. And 52 will be here. Right? Then 67, 49, 33, 70. 67, again, completed this group here. 67, then 49, 33, 17. 49 will be here. 33 will be here, right? And 70 will be here, right? Then 55 and 64. 55 and 64 both will be here in this class, right? And then what? 49, 67, 41, 56. 49, 67, 41, 56. 49, 67, 41, 56, right? Right. And then we have 75, 66, 37, 47. So 75, 66, 37, and 47. Right. Okay. Then 84 and 73. 84 will be here. And 73 will be here. Right. And then we have 57, 38, 48, 69. So 57, then we have 38, then we have 48 and 69, right? Okay. 86, 81, 72, 65. So 86, 81, then 72, and 65 will be here. '53 and 41. So 53 will be here, and 41 will be here, right? Okay. So let's count the frequencies. So here we have a frequency of the first class would be equal to, so this is now so easy to calculate the frequencies, right? So the first is 2, then we have 9, then we have 11, then we have 13, then 11 again, and then we have a frequency of 4, right? So this is the frequency distribution, right? Okay. All right. So these are the 3 steps of constructing the frequency distribution. Now, the 4th step would be to, let's see, to find the class midpoints and class boundaries. Okay. So class midpoints are basically just the middle value of the class interval, right? So basically, you simply take the average of the upper and lower class limit of a class, and that's basically the class midpoint, or what we call the class marks. Okay, so find the class midpoints. I'll just write another name for it, or class marks, and the class boundaries. Okay, so for our example, let's find out the class marks for our example. So the class marks are, so the first class midpoint will be So 24.5, right? So the class midpoints. So the first one will be 24.5. Then we can keep on adding the class width to find out the successive class midpoints or class marks. So the next one will be 36.5, right? Because we have a class width of 12, then 48.5, then 60.5, then 72.5, and 84.5. Okay. So the class midpoints are these values for our example, and which is basically the average of the upper and lower limit of a class. Okay. Now the class boundaries are basically the values in between the upper limit of a class and the lower limit of the immediately next class. Okay. So for example, so which is the value which is right in between these two. So for example, this 30 and 31, we have the average of these two values is basically the first class boundary. In fact, it's a second class boundary because we have a one class boundary should be there at the starting as well. So class boundaries are basically we have one at 30.5, which is the average of 30 and 31, which is right at the middle of the upper limit of the first class and the lower limit of the second class. Then we have, now again, we can keep on adding the class width. So the next one would be 42.5. Then we have 54.5. Then we have 66.5. Then 78.5. Then we have 90.5, right? And we will have actually one more. Which is basically before the lower limit of the first class. And so that will be 18.5. Okay? All right. Now, what are these class marks and class boundaries used for? So typically for a frequency distribution, like, I mean, if you are, like, if we have the raw observations of a data set, then we can compute the several statistical quantities, like, for example, what's the average value of the data in the sample, so that kind of stuff. So, but if you are given, so if you're given the actual observations, then you can very easily compute, let's say, the average value of the data set, right? But if you are given a frequency distribution where we only have the classes in the form of ranges and their corresponding frequencies, then we don't have the information of how many of these observations, let's say, what are the actual values of these two observations, right? So if you're given that for a range of values in between 19 and 30, you have a frequency of 2, but what are those two values, we don't know, right? I mean, for this case, we do know because we actually constructed the frequency distribution from the actual data set. But let's say if you're given a frequency distribution itself, and apart from that, you don't have the actual data set that was used to construct the frequency distribution. So your job is to compute, let's say, the average value of the observations that you have in the frequency distribution, right? So the class marks or the midpoints, we simply use these values as representatives of each class when we compute, let's say, the average value. Okay, so what we do is basically we simply take a weighted average using the class mark of each class to compute the weighted average, and that will give us the average value in the frequency distribution. And obviously that average is not exactly accurate if you compare that average with the actual average, which is had we have the information of every single observation in the data set available to us, we could have calculated the actual average. But if we are given a frequency distribution, then we can use the class marks as representative values for each class to compute the average value of the frequency distribution, right? So we assume that for each class, all the observations have the value equal to the class mark when we compute the, let's say, the average value. So this is one use of the class mark or the mean values. Then the class boundaries are typically used to construct the histogram, which we'll be doing in the next video. So histograms are basically touching bar diagrams, and the goal is to construct the frequency distribution or to represent the frequencies in the form of vertical bars without any gap in between successive classes. And so when we draw histograms for a frequency distribution, we typically use the class boundaries. So these are the two main uses of class marks and class boundaries. So we'll stop here in this video, and in the next video, we'll actually see what are histograms and how we can construct histograms, and how we can draw what are the cumulative frequencies and what are the ogive graphs and all. So I'll stop here and we'll see you guys in the next video.